Hi, welcome to Homely Training for Installers. Pre-course activities. First thing to do before you start with the installer training is to make sure that you've downloaded your Homely installer app. This is critical as this is going to be your means to connect the Homely hub when you arrive on site to the customer and to the internet. And you need to have this working to be able to set up a Homely. As you download the installer app, first thing that you'll see is the first demo system that has been added for you. This is a real live working system connected to a media heat pump. In there, you can explore information, try different things, and just get yourself familiar with how the installer app works. Once you get to site, you'll just add a new hub using the button Add a Hub, and that will walk you through the process of adding a hub. Now, going into the details of what you can see here, first two are hub data and node data. This is the information about the actual Homely kit. So is the Wi-Fi connection okay? Is the temperature sensor that is wireless with Homely, does it have a good battery? Does it have a good signal? The next one is relays. So relays is, I'll talk a bit about it later on. Modbus section. This allows you to see the real-time data of the heat pump. Here you'll see the different temperatures in terms of flow, return temperatures, hot water temperatures, as well as whether there is an error. So if a customer calls up and says that there is an issue with their heat pump, you can actually go into your installer app and check whether there's an error. At the moment, it will say yes or no. In the future, you'll be able to see what that error code actually is. And the last section here is the electricity meters. We don't, at the moment, ask people to install electricity meters, but Homely can actually read an electricity meter that it has Modbus connection. So in there, you could daisy chain the Modbus connection into the heat pump and the electricity meter, and then you could see the information that the customer would be able to see on that electricity meter. Also here, you'll see a commission heat pump button, which I'll talk about it a little bit later on. First, let's take a step back and just agree on what the customer actually wants. So from Homely's perspective, we think that the end customer of a heating system wants to set their temperatures with ease. They want reduced heating bills, reduced carbon emissions, and comfortable and cozy home. An easy way to explain what Homely does is by looking at what Homely doesn't do and comparing it to the on and off thermostats. So we believe that with on and off thermostats, they can lead to heat pumps having worse efficiencies than advertised, higher energy bills, and potentially even shorten the lifetime of the heat pump because you are turning the heat pump on and off and the compressor can wear. Weather compensation, we think is the great solution, but it does have its challenges. At the point of the installation, the information about the property might not be known in advance. So even though we do the heat loss calculations for the house, it might be that those calculations might be slightly off. And if we were to set up a weather compensation data, just using that information that we've collected doing visual inspection, it might be that calculation is incorrect. There is also a possibility that the customer set points, they might want to change them. And with the pure weather compensation without any room thermostat influence, that would mean that the customer needs to interact with the weather compensation curves, which might not be the ideal solution for the end customer. We do believe that the presets are handy. So we have seen that some heat pumps come with a default weather compensation setup, which might be one for radiators and the other one for underfloor, and then you put on a third-party stat, which is on and off control on this system. We believe that does improve the efficiency of the heat pump compared to, for example, running the heat pump continuously at a fixed flow temperature of 55 degrees, but it still doesn't achieve the benefits of the heat pump that have been promised to the customer. So it doesn't achieve the faceplate COPs that we expect. And this is where Homely weather compensation comes in. So when you install a Homely, what you can do is actually forget about setting up the weather compensation. So there's no need to actually input any parameters about the weather compensation into the controller, and Homely will actually do this bit for you. So Homely will, as the system gets installed, Homely will start heating the house straight away, but it will work on this default standard house that we have some parameters for, and then couple of weeks into the heating season, we'll be learning about the house. So by looking at what the internal temperature is doing when we are turning on the heat pump, and because we can also see how much heat the heat pump is producing and how is that influencing the internal temperature of the house, we can then learn this digital image of the house and basically how long did it take for it to heat up and cool down, even to the point of us understanding how much heat it actually picks up from the sun hitting the windows and actually heating up the internal temperature from there. Then once we've learned about the house and we know how it's behaving in certain weather conditions and in different outside temperatures, we can then use the predictions of the weather and solar gains to come up with an optimal heating schedule for this house. And when I mean heating schedule, I don't mean on and off heating schedule. I mean what should be the flow temperatures that we should be sending to the unit to optimize this heat pump to deliver the best in class efficiencies for this heat pump. And in order to do this, we also, of course, take into account the customer set points. So as the customer set points get changed by the customer themselves, for example, we would be amending these flow temperatures that we're sending to the unit. And from the customer's perspective, there would be no weather compensation curve. It would just be flow temperatures that were constantly changing through Homely. So Homely would be every half an hour, Homely will be updating the flow temperature set point on the customer's heat pump, and that's what they would see on the actual heat pump controller. So this is moving away from the on and off thermostats. We can also turn heat pump on and off in certain circumstances. So let's say that you're cooking and the internal temperature rises quite a bit, then Homely could turn the heat pump completely off. But in most cases, what we'd like to see is the heat pump continuously running in the background, running at very, very low flow temperatures, achieving those best-in-class efficiencies and achieving the customer set points. So this is me trying to be funny. It's an equivalent of an engineer sitting there 24/7, changing the weather compensation, looking at the outside, looking at whether it's sunny or not, and constantly interacting with this weather compensation. That's what Homely does for the engineer. In terms of the customer app, it is very simple, and this is the way that we intended it to be. So from our perspective, customers want to set temperatures with ease and just forget about the heat pump, and the heat pump just should do its thing and achieve all their desired outcomes. So comfort in the house, low heating bills, and low carbon emissions. So if you can see here, in terms of the customer app, the front screen is just the information about your current internal temperature. You can have boosts and also the holiday mode, which will be a setback temperature for, let's say, you're going away for 7 days. If you set the holiday mode for 7 days, what Homely will do is it will turn off the heat pump initially, but then 3 days in advance before you come back, it will actually start seeing that there is a higher set point coming up when you're back, and potentially preheat it slowly so that it doesn't need to go full out at the point when you return from holidays. Now, if you go into the hot water menu, this is where you can select the times where you would like the hot water to be warm. So in this case, for example, 6:30 till 8 o'clock. If you need the hot water reheat turn on, and the heating side, you just select the temperatures when you would like the temperatures to be, when you would like the house to be at these temperatures. So 8 till 10 o'clock in the morning, it should be 19.5 degrees, and 6 till 10 o'clock in the evening, it should be 19.5 degrees. It doesn't mean that the heat pump is not going to be running outside of these times. It just means that these are seen by Homely as the minimum temperatures that the customer has selected, and it'll do the best it can to make sure that these are achieved. Now, Homely is more than this. So Homely can actually, in addition to delivering this perfect weather compensation for customers where they have just a single rate tariff throughout the day, Homely can also take into account variable tariffs, such as Octopus Go, Octopus Agile, other EV tariffs where the electricity price is cheaper overnight, and overlay what we know about the house and what we know about the different efficiency of different flow temperatures with the electricity prices. So for example, make a decision that it makes more sense for this house to actually heat at slightly higher flow temperatures in the middle of the night, even though it's colder outside. But if that price difference between night and day is big, in my case, for example, it's 5p overnight, 24p throughout the day, I can be running my heat pump at very high flow temperatures, wasting a little bit of that heat into the outside, but it's still trying to capture as much of that cheap electricity as possible. There is also the second part of what Homely is doing, which is integrating PV and domestic batteries. So Homely was always intended to be that beating heart of the smart home, and here Homely would be interacting through the same connections into the domestic battery, into the heat pump, seeing what the electric vehicle is doing, making sure that the electricity flows are optimized. So battery knows that it needs to charge during specific times, and then heat pump also knows that the battery is there. So it might actually decide that I should charge up the battery in cheaper times of the day to use that electricity using a heat pump. Or in some cases, I might decide to heat my house a little bit more with the cheap electricity tariff so that I can jump through these more expensive periods as well as use my battery during the expensive periods. So Homely can do all of this. We have been testing system with the PV and domestic batteries for around a year, and we are looking now for early alpha testers, early adopters. So if you know anyone, please do give us a shout. And this is the system that we've been testing. So as you can see Homely here in the center, connected over Modbus connection into the heat pump controller, into the battery, a CT clamp attached to the EV charger so that we make sure that we don't discharge the battery into the EV. We also have Homely Cloud, which is your solar forecasting data. So we can see a day in advance that there will be PV, for example, available. And even though, as an example, you have a very cheap electricity overnight, it might be that it makes more sense to not charge the battery fully because it's a very sunny day and we want to make sure that we have enough room in the battery to soak that EV up. And also the electricity prices. So whether it's Octopus Go, Octopus Agile, we can actually integrate these electricity tariffs into the decision making of this whole house optimization. Installer benefits. Just reiterating the installer benefits, it's the auto-adapting weather compensation so that you don't need to set up the weather compensation, no more guesswork. Heat pump working as promised for the customers, so achieving the efficiencies that have been stated on the faceplate. It's also happy customers, reduce servicing overheads because you can see all this data remotely, and greener future because you're going to be achieving better efficiencies out of these heat pumps by making sure that they run in this most efficient way possible. I've mentioned at the very beginning that I'll talk a little bit about the remote commissioning. Remote commissioning is this button over here. So you know when you get to site and you need to enter parameters into the controller so that it sets up the controller. As an example, you need to specify where the immersion has been connected, whether it's connected to a separate timer or the heat pump itself. Here, we can actually do that all for you. So at the point of the installation, media controller doesn't even need to be touched. You enter some information when you're adding a Homely hub, and then we using this information will ping through the parameters into the media controller. And yes, you won't need to actually interact with the controller itself, which saves time on the installation and also avoids potentially human error. Or sometimes if the end customer has changed something, you can actually revert it back to what it was at the point of the installation. Homely dashboard. So Homely dashboard was not, this is not the final version of the Homely dashboard. It was a dashboard that we were using internally, and some installers actually wanted to see this same information because it was helping them identify issues of heat pumps before they get to site. We've said that it will make it available, but there are still quite a few things to work out, and the presentation, the dashboard itself is going to change drastically through time. So whatever we have here is just the first internal iteration of what we're using. We made it available to installers because they said that even though we don't have the final version, they would still like to see this information available. So I'll do a separate session on the dashboard, but we can see here in short is some summary statistics and about this heat pump. So this heat pump over the period of selected time frame, which would be 14th till the 7th till the 16th, has had a COP of 4.66. In terms of the information here, you'll see the indoor temperatures, set points, flow temperatures, return temperatures, when the heat pump was actually active, running in heating, flow rates, hot water temperatures, refrigerant temperatures. Basically, the information that we can get out of the Modbus registers on the heat pump, we will be presenting it here. If we're not presenting something and that you would like to see, let us know and we'll add it into that dashboard. Most importantly, there is also the Modbus alerts at the bottom. So over here, you can see when the Modbus alert was thrown. This is an alert that is coming up on the heat pump. And here you can also see what it means. So if the customer calls up and says that they don't have heating, you go into the dashboard, you check that if there are any errors being thrown, and this could help you identify an issue and the parts that you need to bring to site to fix the problem. Homely has 3 different modes. So there's standard, smart, and smart plus. Standard and smart modes are suited for single rate tariffs. So this is where the electricity price does not change throughout the day, 32p per kilowatt hour. And it doesn't matter whether you're using the electricity overnight or during the day, you'll still be paying the same electricity price. We also have Smart Plus, which is suitable for tariffs like the EV tariffs, cheap overnight, or even to the point where Agile, and the Agile tariff is published every day at 4:30 p.m. This is when we download it from Octopus servers. We can actually optimize the heat pump behavior around these half-hourly prices for the next day. So we're seeing the electricity prices for the next day, we're seeing weather forecasts for the next day, and then we can make the right decisions around these electricity prices and the efficiencies of the heat pump. With hot water, depending on whether you're in or smart mode, standard mode was more created for people that they don't want the heat pump to run outside of the times that they have specified. It is very important to let the customers know in standard mode the electricity costs, the running costs of the heat pump might increase because they're not allowing the heat pump to actually run at the very low flow temperatures. Whenever the set point goes active, the heat pump needs to work really hard to get you to set point and then maintain that set point. This is not ideal for the way that heat pumps work, but if it's the customer requirement, they can actually choose this. So standard and smart mode in hot water. In terms of hot water, what they will do is if in the app you've selected 7 till 8 and that you would like the hot water to be on, in standard mode, heat pump is not allowed to run outside of these times. So the heat pump will turn on the reheat period. So on the heat pump, it will actually turn on the reheat of the hot water, and that will run between 7 and 8 o'clock in the morning. In smart mode, what we do is we add another hour before the time that you are going to get up, so that by the time that the customer gets up at 7 o'clock, the hot water would have been in reheat for that whole hour, and the customer would then have hot water already. So this is a kind of like a preheat function in the smart mode. If you're looking at Smart Plus actually selects the 3 cheapest periods of electricity for preheating the hot water cylinder. So in this example, if we were to say that you were using agile tariff, so every half an hour price is different, and you had scheduled times for hot water again between 7 and 8 o'clock in the morning. Just for comparison, in smart mode, you would have had the hot water preheat an hour before, and then hot water reheat would have been on for the whole 2 hours. In Smart Plus, what would happen is that we would be looking at the electricity prices before the time that you've set your hot water. So here in this example, it would be 7 till 8, and picking out the cheapest 3 half hours in which we're going to turn on the hot water reheat. So in this case, it's 12 o'clock when the electricity price is 4.52p, 3:30 for half an hour when the electricity price is 5.63, and then 4:30 when the electricity price is 5.67. Now, heating mode is the bit that is really important in smart mode and standard mode to be explained to the customer. In smart mode, this is your heating in that perfect weather compensation world. So what the customer actually sets up when they are selecting their set points is the minimum temperatures that they would like to be maintained at specific times of the day. And in this case, it would be 20.5 degrees in the morning, 20.5 degrees in the evening. The customer should only set the times that they need these minimum temperatures so that Homely can have the flexibility around these set points to actually make the right decisions for them. And in smart mode, heat pump is going to run for long periods of time trying to use the heat pump at those very low flow temperatures, achieving the high COPs for the heat pump. The actual flow temperatures that we'll choose will depend on different things like how quickly the house heats up, how quickly the house loses heat, what should be the flow temperature that we're going to need to send to the unit. And all of these trade-offs are going to be taken into account, including the weather forecast, to derive that best, most efficient schedule of heating for the customer so that they have their house at 20.5 degrees between 8 and 10 and 20.5 degrees between 6 and 10 o'clock in the evening. In standard mode, so this is where, again, the customer doesn't want the heat pump to be running outside of the times that they've specified. If you look at this graph, the information presented here is the temperature, so we can see that axis is temperature. Internal temperature is the orange line. The set point of the customer is the green line over here. These are COPs estimated, and also the outside temperature presented by this green curve here. What we can see from this graph is that a customer has a set point between 8 o'clock and 10 o'clock in the evening. So the customer has a set point of 20 degrees throughout the whole day. They are in standard mode, which means that the heat pump is not allowed to run outside of these times. And if we start off at 12 o'clock at night at 20 degrees indoors, the house is actually going to be cooling down all the way up to 8 o'clock in the morning, at which point the heat pump will kick in and go full blast to get the internal temperature of the house as quickly as it can to the desired set point of 20 degrees. That the customer has selected. This means that the heat pump is going to be running at very high flow temperatures. The COPs that it's going to be achieving are going to be very low. The reason why I've said low efficiency, low comfort is because in the morning when they get up, the customer is going to be colder than they would like. So instead of 20 degrees that they've selected, they're actually going to be, let's say, 18, 17. This will depend on the house and the leakiness of the house. And then it will take quite a bit of time for them to get to temperature. The low efficiency part comes in where the actual flow temperatures here are going to be very high, which will mean that the heat pump is running for a shorter period of time throughout the day at very high flow temperatures, which means low efficiencies. And then throughout the rest of the day, the heat pump then goes into that perfect weather compensation that we've been talking about before. Now, in smart mode, this is where Homely can actually make some decisions around the set points that the customer has selected and make the heat pump run in a slightly smarter way. Here, what we can see is if the customer, let's say, had a set point of 18 degrees in the morning and 20 degrees in the evening, what Homely would be doing is it would actually be on even at 12 o'clock at night, at 1 o'clock at night, because the temperature outside is still a little bit warmer. So keeping that temperature, not letting that internal temperature drop too much. Then as the temperature approaches zero, because the efficiency of the heat pump actually gets quite low, the heat pump is going to turn off. And then at 4 o'clock, it turns on again, but with very low flow temperatures, and kind of slowly lands the internal temperature at the customer set point for the morning. The behavior here will depend on, again, every house is going to be different, and it might actually be that the best scenario for this house is to just keep the house at 20 degrees with very, very low flow temperatures all the way throughout the day. Homely will make these decisions for the customer, and they just need to trust that the customer is doing the right thing. Then throughout the day, what we can see here is that the internal temperature starts slowly rising to the evening set point. So the heat pump is not working super hard, but it's gradually raising these flow temperatures so that it can achieve the desired set point for the evening. This is where smart mode is going to be running almost continuously throughout the day with low flow temperatures, achieving high efficiencies for the customer and the lowest cost. So even though the heat pump runs for longer, because you're achieving much greater efficiencies than in the other scenario, this will actually help you achieve the desired outcome of comfort and efficiencies. I've added this in the snapshot of the dashboard in just so that we can show the behavior of this in Smart Plus mode, which is our tariff optimization service, but also to show you how Homely actually does whatever we were just talking about before. So if you look at the graph here, these are the set points of the customer. So 20 degrees throughout the day and 22 degrees in the evening. For this customer, the internal temperature has been slowly rising towards that evening set point, and as you can see here, the flow temperatures have been slowly decreasing throughout the day so that the house gets warmed up slowly. Even at the 10 degrees outside, the heat pump was running at nearly 35 flow temperature, just trying to maintain that 22 degrees indoors. As this customer was on a variable electricity tariff and they were on Smart Plus mode, there is also a function called Cool Night mode. And Cool Night mode, what it does is it limits the preheating of the house overnight. Even though the electricity price is cheaper, sometimes customers might not want the house to be heated as much. What the Cool Night mode does is it limits the preheating of the house during the cheap electricity tariffs. Between the last set point of the day and the first set point of the day, it just puts in a maximum temperature that we can get to as the first set point of the day. So in here, maximum temperature that the Homely was able to get to overnight was 20 degrees. Which is the set point in the morning. So you can see how internal temperature dropped below that maximum temperature because the electricity price was so cheap. It was trying to get this temperature as much as it can to the set point, and it also did the hot water reheat. This is not the advised way to use the Smart Plus function. If it is for comfort that you're trying to reduce the impact of temperatures in rooms such as bedrooms, it should be just that in the bedrooms you can turn the radiators off so that the bedrooms stay cool, but the rest of the house should actually be preheating for that day so that you can utilize as much of that cheap electricity as possible. That's what we normally advise customers to do. So just to summarize, in smart mode, it's suitable for single rate tariffs, so where the price of electricity doesn't change throughout the day. Hot water reheat activation is going to be only for an hour before the customer sets their time for the set points. So if you have a set point between 7 and 8 o'clock in the morning, hot water reheat on the heat pump is going to turn on an hour before, so 6 till 8 o'clock in the morning. And in terms of the heating, it will likely be running outside of the times that have been specified by the customer. This is to make sure that the heat pump is delivering that heat into the house at the lowest flow temperatures possible. So even if there is a set point, let's say at 7 a.m. in the morning, and you're currently at 20 degrees and it's midnight, the heat pump might already be running, trying to make sure that it doesn't lose too much heat overnight so that it doesn't need to run that heat pump really hard when it needs to actually get to your set point later on. In standard mode, you'll see that the hot water reheat is going to turn on as per the scheduled times, and the heating will only come on at the scheduled times. This will mean that the flow temperatures of the heat pump will be much higher than they would have been in smart mode, and they'll see just the heat pump going flat out at the points when their set point goes below whatever they've set, especially at the beginning of those set points, because the house would have cooled down, let's say, before the morning set point. This will lead to higher flow temperatures, which will mean lower efficiencies, which will mean higher cost to the end customer. We do provide a lot of information. So standard mode was created so that customers have the choice. We do hope that by providing information around smart and standard mode and their the working principles and why smart mode is actually cheaper, and we should be able to give the customer the information required for them to make an informed decision whether they would like to go for standard or smart mode. And the last is Smart Plus. So this is, as mentioned before, it's suitable for the EV tariffs like the cheap overnight or agile tariff. In terms of the hot water reheat, it will pick the cheapest 3 periods before the set times for the hot water. So it'll try to utilize those cheap electricity pockets. And for the rest of the day, the hot water reheat is actually going to be turned off. So if the customers have more than expected hot water demand during the day, they would need to use the hot water boost to heat their hot water tank with electricity that might not actually be the cheapest. In terms of the heat pump will be running more during the cheap times while still considering the efficiency of the heat pump at different flow temperatures and the heat loss of the house. Here, there are loads of factors that we'll take into account, and we'll just make sure that we're utilizing those cheap tariffs as much as we can. In terms of the installation of the Homely, there are a couple of requirements at the moment. So you need to make sure that the distance between the Homely hub and the wireless temperature sensor, which we call the Homely node, needs to be less than 8 meters. This is a limitation of the radio that we're using at the moment. It will be improved in the future. At the moment, you just need to make sure that that distance is maintained so that you don't have issues with node disconnections, so the temperature sensor losing signal to the actual Homely hub. You'll also need to make sure that there is a 3-pin plug wherever you're going to place the Homely hub itself. And at the moment, we only support single zone. We will in the future be able to support dual zone systems. We don't think that at the moment they can actually achieve the desired effect of lowering the running costs of the heat pump for the customers. The reason here would be that if you have 2 rooms, one is heated to 24 degrees, the other heated to 22 degrees, some of the heat that you're going to be delivering to the warmer room is actually going to be leaking out into the colder rooms, which will mean that the room that you're heating with higher now to 24 degrees with high flow temperatures needs higher flow temperatures what they could have done if both rooms were kept at 24 degrees, and that could actually lead to higher costs of running the heat pump. Dual zone, as I said, in some cases it does make sense, but that support will be only coming in the new year. If you do have an issue in terms of the distance, so Homely hub Homely node usually needs to be placed in the living room, so it is usually the Homely hub that you'll need to manage, so you'll need to actually place the Homely hub closer to where the node is going to be. You can do that by extending the Modbus cable. So Modbus cable will be extended up to 30 meters, and that would allow you to place the Homely hub close to the node so that there are no connectivity issues between the hub and the temperature sensor. In terms of the installation, I am just showing here the installation on the Midea heat pump. Both Samsung, LG, Daikin, Midea the information about this installation will be provided in a sec. Here, what we need to do with the Midea is connect the Homely hub to a heat pump. So you do this by connecting the cables that are coming out of the Homely hub into the H1 and H2 signals, as well as putting in the provided resistor. So resistor comes in the box with a Homely that is going to go across the H1 and H2 terminals. Here we've shown that you can actually extend the cable that is coming from the Homely hub by using the gel connectors that have been provided using a stranded Cat5 cable. Once you've connected into the heat pump itself, you need to power up the Homely and then follow the on-screen instructions in the installer app to actually complete the installation. On the Samsung, it is important to first identify, before you even buy a Homely, you need to identify whether you're using a pulse width modulation pump on the primary side or a fixed speed pump. This will determine which kit you actually need to use. We would always advise using the pulse width modulation pump on the Samsungs for improved efficiencies of the heat pump. You can find the installation manuals in the email that we'll send through. There you can see how the different installations actually need to be happening. On the Midea, all the information is provided in the installation manual, but the quick run through before was more or less what we've seen from our experience. In a lot of cases, the issues around Homely arise from the misunderstanding of whether the Homely is doing the right thing. So in smart mode, sometimes customers might not feel as though their heat pump is running effectively if the heat pump is running outside of their set times. So in a case where, for example, you have a set point of 18 degrees in the morning, it's 20 degrees in the house and it's midnight and the heat pump is running still. Sometimes that seems strange for the end customer. This is where Homely is doing the right thing by trying to keep the flow temperatures really low so that it can maximize the efficiencies. But from the customer's perspective, it could seem like a waste of energy. We are doing a lot in trying to communicate why Homely is doing this thing. Homely has a lot of information in app. We try to do our best there. But the most important thing to just communicate before you go away from your installation is to tell the customer that heat pump should be running almost continuously throughout the day. And that message of slow and steady wins the race is very, very important. You also need to let the customer know the radiators will feel cool to the touch whenever the outside temperatures are at warmer outside, because the heat pump might be running at 35, 30-degree flow temperature, which if you touch the radiators, they're actually going to seem cool. That is, again, Homely is doing the right thing by maintaining the indoor temperatures that the customer has requested with the lowest flow temperatures possible. So maximizing the efficiencies and maximizing the comfort whilst minimizing the cost of running the heat pump. Few other things just at the point of the installation is to check the wiring of the heat pump. Once you've followed all the steps in the installer app, installing a Homely, click on the Modbus menu on the installation that you've just done and just see whether you can see all the data coming back from the heat pump. This is just to make sure that the heat pump and the Homely hub are actually communicating over Modbus. So Modbus is our communication with the heat pump. It's two cables through which we can actually see all of this information. Then we also ask installers to check whether the heat pump is able to do the things that it's told. So here through the relays menu that I've shown before in the installer app, what you can do is you can force the heating of the heat pump to turn on. What this does, it disables the customer set points for half an hour, and it allows the engineers to do the commissioning checks on the heat pump. So if you toggle the heating on in this screen, what heat pump will do is it will go into heating mode, and it will also bump up the flow temperatures to 45 degrees so that you can check whether the 3-port valve is correctly connected. If you leave it running for 10 minutes, you can also see whether the pipes are going into the right direction, whether the heat pump is running and actually achieving raising these flow temperatures so that you can see that no errors have appeared. Then you can turn off the heating, turn on hot water. So hot water here will actually force the heat pump to go into hot water, and depending on the heat pump that you've selected, it will bump up hot water temperature set point for that period of half an hour. So the half an hour for you to do your commissioning checks to the maximum available. So on the MIDI, it actually is 65 degrees. So once you press the toggle for the hot water, what you'll see on the controller of the media is that hot water temperatures goes up to 65 degrees, and the hot water is actually going to start running. Again, to make sure that everything is working fine on the installation. I had a couple of questions about the Zone 1 and Zone 2. Zone 1, at the moment, we only support single zone systems. So if you toggle the heating cursor, you'll see that the Zone 1 is going to turn on. Vice versa, if you were to toggle Zone 1, you would actually see that the heating comes on. Just ignore the Zone 2, and this will become available for those systems that are being installed with a second temperature sensor. Once the half an hour of the commissioning has passed, even with the hot water, so for that half an hour period, the hot water set point is going to be bumped up to 65 degrees. Once that half an hour has passed, the Homely will revert back to the customer's controls, and it will revert back to whatever the customer has selected as their preferred hot water temperatures. And just on our first installation, we do ask to give us a call. So when you're doing the installation and when you're done, whilst you're still on site, if you can give us a call to our tech support team, we can actually do some checks together with you so that once you leave the site, you are confident that the system has been installed correctly. That first experience is really important for us in terms of your experience installing a Homely, as well as the customer's experience using a Homely. So we don't want there to be any snags. And this is where the first installation is critical in building that trust in the product. So if you give us a call, we'll be able to check through quite a lot of information that is coming back from the heat pump so that we can see whether everything has been set up correctly.